anything stupid with it.
What could possibly go wrong? Okay, Jitsi screen sharing.
Probably on Reddit already.
So this is live on YouTube and it's working.
Are we going to have to go out of the tile view to be able to see the shared doc now? Or are we going to override the shared doc when we talk?
So if there is some sharing, then I don't think it's going to be peeking out. So okay.
How about that?
Okay.
That looks good.
Yeah, nice.
Looks good to me, yeah.
Does it update live properly? Let's see. Yeah, nice, thanks.
Cool.
Looks like you can't see my face, but I'm sure you'll all survive.
You can turn the camera back on if you want, but I know what you look like.
Oh, that works.
Right, so who's driving?
Wait,
no,
actually, the quality is shit right now on the screen.
maybe camera off.
Yeah,
Okay. How's that?
much better. A little bit better. Oh, much better now. Okay.
There we go. Yeah.
Okay, cool.
Okay.
Walk into the
Can you increase the font size? I mean, this is a 720p stream.
Yeah,
Yes. Okay.
There we go.
nice.
Okay. I'll leave you guys to it.
Okay. All right, so thanks everyone who joined. No, Martin, come back. Yeah, that's great that we can have a discussion even though we are not in person. Basically, yeah, the idea for the workshop was to get some feedback and any feedback you could have on the allocation constraint we suggested yesterday. And yeah, if you have any questions, anything you didn't understood about the talk, maybe now is a good time. Yeah, please add yourself in the list if possible. Yeah. I don't know how how well this will work. We'll see. Okay. And then after any questions, if there are any answered, maybe yeah, just ask what you think about the design. We'd like first to have some more high-level feedback, just to make sure we're not completely in the wrong direction. And then if we can agree on something, then maybe we can dig up some other details later. Yeah. So yeah, maybe first, any questions about the talk itself? I mean, if it was very clear, I mean, that's a good thing.
Yeah, I thought it made sense. One tiny bit of low-hanging fruit that occurred to me is, you know, rather than, at least for the Wayland side, I imagine rather than blasting these whole huge lists over the wire, it might be better to do our usual nonsense and use an mmapped FD. So I was thinking maybe it would make sense to, in the library, have just a really dumb canonical serialize, deserialize.
Yeah, that might be a good idea to have like a map of modifiers to constraint sets. So we already have a serialization for constraint sets, but not, yeah. Yeah. Maybe I should link the DRM constraints code somewhere. Like there. Yep.
Cool.
So basically the idea, is just to have a flat list of 64-bit integers with a header and the constraint body data. And you just have a list of these. And you can represent constraint sets with this. So yeah, all of this should work fine on the wire. Maybe we should add something because it's a lot of level of indirections. You have modifiers, and for each modifier you have like a variable list, so a list of variable length. So yeah, it's getting complicated a little.
Yeah,
okay.
we tried at first to do just a uint64 for each constraint, like we have with modifiers, but the constraints just get too complex, especially with the heap ID one. You really want a list of things. So we went with something variable length, evolved from the modifier stuff.
Okay. Anything else? All right. So yeah, maybe you can just go through the different high-level items. So did it make sense the way we used existing APIs to query usage? Or do you have better ideas for this? Like query KMS, query ETL, Vulkan?
So yeah, I think I was cutting out at kind of a critical time. Either that or we'd just talked so much over the time that you had to smash through it. But for the EGL query, you said something about like texturing versus FBO versus whatever you said, but it wasn't clear how that was expressed in the API. So would that be that like texture is a cap and render target is a cap, or do you have specific usage flags for that, or?
So in the proposal we had the external only flag. I'm not that familiar with like why it's called external only and not something else.
External only is so when you bind an EGL image as texture 2D, it allows you to do a bunch of stuff to it. It opens up the possibility that you can write to it, but it also implies that you can use filtering modes like bilinear or whatever. Whereas for texture external OES, it's super limited in that you can't do exotic filtering modes. It's very strictly read-only and all that kind of stuff. So there are some devices which will, like say Vivante, that can import YUV and it can address it natively, but they plumbed it in such that you can't do like texture filtering on YUV. So that is just a hint to say that when you import something with this format and or modifier set, you can only bind it to texture external rather than texture 2D.
Okay. So maybe it's not the right tool for the job.
Yeah,
I mean, that's what we use for modifiers, though. So I was hoping that it could use the same thing, because it seems like if you can bind something to a regular GL texture target, you more or less have to assume it can be rendered to, unless you want to go and get really fiddly with the specs. So yeah, so when we were talking about it, I agree. It's not the exact fit, but it seems like what we're using. So I don't know if this use case is different than modifiers somehow. That'd be good to hear.
It was more formats than modifiers is the reason we put it in there. I know it's definitely Mali and Vivante that have exotic ways of handling YUV. Yeah, I don't know. Yeah, I think it's close, but not quite. But that's fine. So yeah, that makes sense. Thanks.
Okay. Yeah. Will it be fine to to make you happy? Call it something else, but keep it a bool, or yeah, I don't know.
If this is our biggest problem, I am so happy already.
All right, good thing.
Like one of those, we'll probably submit the patch this way, and then if someone has the use case where that doesn't work at all for them, they're welcome to knack it or whatever.
Yeah. Okay. So okay. Fair enough. Okay. Okay. Yeah. Maybe that was a little bit digging into the details already. So yeah. Did it make sense the way we used one constraint set for each modifier or layout? Or maybe do we need, is this fine? Because someone reacted and said, yeah, we really have different constraints for different modifiers. So is this granularity enough or too much? Or
I think the obvious example here is linear versus non-linear has very commonly different constraints in, for example, the alignment constraint already.
Oh yeah, AMD with aligned to the tiles and everything. Yeah, that's good. Right.
So does Intel and basically everyone else. Yeah, it's definitely very modifier dependent.
Okay, so very good thing we tied it to the modifiers then. So are modifiers and usage enough to say these are the constraints, or do we need something else?
I'd be looking at Buzz because from all I've seen, you guys have, NVIDIA seems to have the most orthogonal modifier setup where essentially everything is possible no matter what you do, if not optimal, whereas AMD seems to be the one with the weirdest restrictions.
I don't think we have anything that's special. I mean, in the end, a driver needs to allocate something even for non-shared buffer at creation time as well, and that's what we're getting anyway, even when non-shared. And we don't do any strange migration tricks with allocation, so I think that should be fine.
Okay. Okay. Okay, good. All right. So do you think the way we have common logic to merge constraints in a shared library or shared code is good? I think there was a question about do we really need to merge to make users like compositors merge constraints? Can't we do it at allocation time? But yeah, we don't really want to have a list of constraint sets. It's a little annoying. So yeah, did that make sense?
I was thinking about that question this morning too, and I wonder if part of the reasoning behind that question was that with modifiers, you want to defer the choice of which modifier to use down to the allocation library. But with constraints, it doesn't matter. When you merge them, it's always going to be a deterministic result. So you don't really need that. You don't really need to defer. There's no benefit to deferring. So maybe that illustrates why that question was asked or something. I'm not sure, but it's worth thinking about.
Yeah, so the common merging logic only works if we have generic constraints. Once we begin to have vendor-specific constraints, this becomes a little bit more complicated. Okay. And then, yeah, provide the constraint set to allocation API of choice, I guess. Yeah, so allocation API of choice here is, we've thought mainly about GBM and Vulkan. I don't know if we need to think about anything else. Yeah. James, did you have anything in mind for the high-level design? Anything else in mind?
I think
Sorry, I'm getting like 1 FPS on my computer trying to use all this stuff, but no, I just wanted to walk through it, yeah, and make sure everyone didn't have major objections before we tried to discuss the details, because that would be counterproductive.
When it comes to the allocation library, you mentioned it's mostly going to be GBM and Vulkan. I was wondering how that would then work on the backends if we want to allocate buffers for cameras. That's don't necessarily need to be rendered. I have absolutely no objection using something like GBM, for instance, to locate buffers that will be shared between a capture device and a video encoder. But that only works as long as GBM could give me a buffer that wouldn't involve the display device or GPU. And I'm not sure if we want to go in that direction.
GBM is not actually a generic buffer manager.
Yeah.
The G definitely stands for graphics.
Graphics, yeah. So do we want to have a layer that would go on top of that, and with GBM would be one backend when graphics is involved, possibly, and where other backends would also be available?
Well, I suppose it's down to, I'm not intuitively sure where it would go, because it seems wildly inappropriate for like libv for L2, but it seems like the kernel API probably wants to be something like DMA heaps, but then you have to have in user space something which is going to, determine the overall size.
Yep.
For example. Yeah, nothing really jumps out at me as to what that is. Maybe we need a VBM or CBM.
We definitely kind of, and this is why we punted here. This part's hard. I think the good part about this design in that regard, though, is that these can be plugged into any API. It's just another parameter. So if we do get, the all wonderful unified allocator, it can use these still. If we don't, then we can have 14 different allocators that take these as input and can allocate various bits, and you try them all until you get one, I guess, which sucks, but it's better than what we have now.
Yeah, and I think that also allows experimenting with different approaches for allocators and still having the constraint resolution in a single place. And then hopefully with time, maybe GBM will evolve into something that's a bit more generic, or it will be laying on top, or it will be something else. I have absolutely no idea, but hopefully we'll find a good solution at some point. But it can be handled at least as an orthogonal problem, which is good.
Yeah, and if we never get a unified allocator API, at the low level, I'm 100% sure someone's going to write one, or maybe someone's going to layer graph on top of this or whatever.
Yeah.
So someone's going to solve it somehow. I just don't really know how, and I don't care, to be honest, that much. This doesn't seem like the interesting part of the problem to me. It's certainly a good problem to solve. I'm just getting tired of working on this problem personally.
I mean, as long as we can expose the constraints on the camera side and give that to the library that will then merge that with the constraints on the display side, and the resulting constraint will be completely agnostic of the fact that there's a camera. And then if there's a display device that's suitable to provide buffers, then GBM could work in that case completely transparently and even not knowing that would be the camera. So I think that's fine.
Yeah. The goal is no matter what API you use, you get usable memory. They might add each API might add its own weird implicit constraints or whatever, but they're all supposed to work in theory.
Right.
At least they should evolve towards all working in the long term, world of theory, where code does not run.
Yeah, redesigning memory allocation, buffer management for cameras. So I'm sure there will be interesting tips that we can get from GBM about the things that should be done or should not be done. So and have a closer look at that. But it also means that it's kind of a blank slate for now, and we can also model it in a way that will integrate with this. So that should make it easier to.
Okay.
Yeah, I think we can definitely move forward assuming GBM as the lowest common denominator for now, at least, because it seems pretty unusual that you'd allocate a buffer for a camera through a generic API that then would not be used by GPU or display. So it seems like, at least for what we're doing now, it's probably always going to be possible to use GBM.
There's a common use case of capturing video for the purpose of encoding. So you just share the buffer between the camera and the hardware encoder and the display.
Yeah.
Yeah. So, and GBM doesn't work well with, so is not really designed for video hardware encoding, or?
I'll defer to Daniel to reply.
I mean, it just doesn't have any. Well, it doesn't have any concept of non-DRI devices to begin with. Like, you can't pass a dev video 12 or whatever FD, but also this is more one for Laurent, but I'd guess it might fall apart on some of the auxiliary scratch state buffers that that Codecs used. But this might be completely wrong, because the last time I touched anything Codec was about 10 years ago.
Definitely scratch buffers that can be involved, but those usually don't need to be shared, so they are handled completely inside the driver. Possibly userspace needs to care about them, but then they can be allocated. Today with the codec API, the default API, it can be completely local. So as long as we don't have to share them, that's fairly easy.
Okay. All right. Maybe we can move on to the next question. Basically, does your hardware has weird limitations that make it not work with this proposal? Or what kind of hardware limitations will be testing the limits of the proposal, let's say?
The most annoying ones I've seen, again, on the camera side, is the requirement to allocate the Luma and Chroma planes in two different DRAM banks. All the rest is fairly common. It's about being physically contiguous or DMA contiguous and alignment constraints. That's really trivial.
Okay, that sounds not that bad. Like this.
Yeah, at least from the ones I know of, the main difficult case is Vivante needing to allocate shadow buffers in different layouts and do transitions between them. But I think that's so weird and painful, there's probably not much we can do about it. I suppose the other thing that would probably be good to point out in terms of scope is that this isn't solving global optimality. Like the biggest problem with modifiers is that you start enabling exotic tiled and compressed layouts, and then suddenly your third monitor can't light up because you've blown through the FIFO, or like on Rockchip where you only have one shared decompressor. So I think it'd be good to point out somewhere that this is not an attempt to boil that ocean.
Yeah, so we don't.
I mean, it's really about
Yeah.
sort of local end-to-end optimality rather than, fully global. We'll consider the entire system and tell you the best thing to do.
Yeah. Yeah. Yeah, these limitations for modifiers are a little bit annoying and require user space to do a lot of atomic test commits, for instance, and things like this. Yeah. Anything else? Because so the constraints we've thought about. Let me just find where is the thing? There. Yep. So we thought about some alignment constraints, pitch alignment, max pitch, something like contiguous, interleaved, placement restrictions like this. There's memory heap constraints that we will need to discuss later. So would we need any vendor-specific stuff, or is it fine just to have these generic constraints?
And I think vendor-specific is slightly confusing here.
Yeah, that's true.
It would be fine, but if you need vendor opaque, I don't know, something like that would be hard. If you want to add your, I don't know, Samsung constraint needs to live in, LPDDR3 bank 2 or something like that, that'll work fine. But if you want to hide that and only expose it on your BSP or something like that and not merge it upstream, I think that gets very difficult. So we're hoping we don't need any of those.
What would be the use case for that?
You're right. Yeah, I don't know.
Okay.
I remember last year that Simon presented something that he had an algorithm where you could actually plug in some vendor constraints.
Oh yeah, the liblifter thing. Yeah. So that was to speed up the process to given a scene graph, so a bunch of buffers you want to place on screen, to speed up the plane allocation. So figuring out how to configure some hardware planes to display these buffers. But yeah, it was not really about I guess, yeah, in a way.
Yeah, can you not sort of use the same idea and do it for constraints? At least leave the door open.
Yeah, so there are two things. So this thing was about deciding how to use the hardware in the best way, but this question is about the constraints themselves. Because deciding what the constraints are or what would be the best solution to display something on screen is something, but the mechanism to communicate the constraints to the constraints themselves, they can't. Yeah, I mean, what you're suggesting is basically having some code in a shell, some driver-specific code in a shell library, and the constraints themselves are just data, so it's a little bit different. I'm not sure it's very clear.
Yeah, it was just an idea. I'm not sort of keen on it. It's just thinking if
I guess in any case, even if we go with our current design, we could always at some point decide that we really need some vendor specific constraints, but that they need to be registered in a kernel header or something, just like modifiers. And then we can add some namespaces for these constraints and keep the old constraints, generic constraints as well. So even if we are wrong on that, it's not that bad. The main issue is that merging code will be to have vendor-specific stuff in it. So that's a little annoying.
So one of the issues we had when we were doing some integration between display and video was that we needed to pass on some sort of sideband constraint. So our ISP had some, in order to do the compression properly, it will add extra pixels on a border in order to be able to compress that were not supposed to be visible. And you had to basically say, I've allocated you a buffer, but it's actually 5 pixels wider than what you actually need to use. And we had no way of using modifiers. Well, we didn't want to pollute modifiers for doing that. And it also depended on if the ISP used that border or not.
So yeah, it will be possible to express that with a constraint that but then you still need to get once you've allocated the buffer with the right constraint, you still need to down the line say, oh, there are five extra pixels on the right, so don't use them or don't display them, right?
Yeah, we wanted to use we could use the constraints as a way of passing that information, sideband information. Like this is a buffer that is constrained in the number of pixels.
Yeah, so the constraints come from the APIs and go to the allocator. So the OpenGL says, I want this constraint, and then the allocator allocates a buffer with the constraints, but they don't go in the other way around. So once you have a buffer and you import it in OpenGL, then the constraint set disappear. They are not communicated. So maybe that's an issue for this use case.
It is a bit of an issue because you can't, once you allocate the buffers, you can't put the real size into the buffer because, for example, DRM is going to check a lot of things. So if you requested a 1080p buffer and the buffer is 1084 pixels, some of the DRM checks might fail.
Yeah.
Is that true? We pad up some of our buffers on the height size.
Yeah, but you're lying about them, right? You don't tell DRM that that's your
DRM we do that too, yeah.
Well, I mean, in the main, you just treat that as an over wide pitch and then an over tall height. Like it's no over tall size. Sorry. So you leave width and height the same. You just have a larger pitch and then a larger size, and it's unused MISC.
Yeah, but when you do the CRT checking and you want to see if the buffer you have is enough for displaying, some of the checks are a bit more sensitive.
Yeah, but as long as you keep the width and height you've reported as the width and height that was requested, you're then free to modify the pitch, which effectively gives you extra width, and you're free to modify the size, which effectively gives you extra height.
Okay, I don't want to take on this. Yeah, that's fine.
It can be hard to find the size sometimes of a buffer. Or we found anyway. But I think on a DMA buff, you can LSeq on it or something like that, and it gives you the size. Ran into that problem when we were doing the Vulkan stuff too.
Okay. Anything else? All right. So the next easy question, let's say, is where does the constraint merging library go? So we had we've decided to put it in a header because in a kernel UAPI header because it's the simplest solution. But there are some potential other solutions. I think I've listed some somewhere. Yeah, I think it's in the email description, in the email archive. One idea would be to put it as a syscall DRM IOCTL or something, so that it will stay in the kernel. Maybe that will be a little bit costly or something. I don't know. Maybe a little bit heavyweight is a good idea. It's a good way to put it.
So yesterday on RSC, I mentioned we could put it in the VDSO because to call in user spaces, and you for free get like an updated version of the resolver if there's like new constraints that it has learned how to handle. So say an older app would automatically handle new type of constraints that new device drivers that was like bundled with that kernel would offer or provide. Yeah,
that's pretty interesting. I didn't think of that. So can you just add stuff in the VDSO in any Linux subsystem, or are there more?
No, so in the kernel it's a generic framework. I know that there are other ideas now to extend it with similar things. So like discussing this on the Linux kernel mailing list might be interesting to see, because there's some code and potentially no data really. It's just executable code that we need to expose to user space.
Cool. Yeah, that's a cool idea. Yeah, it might be a good solution. Because so maybe we'll definitely need still a UAPI header. I think for the defines with the constraint names and versions and everything like this.
Yeah, but that's the standard how VDSO works. It basically has all the defines and all the function entry points into the VDSO defined, and then you just call it.
Okay. Yeah, and a very big problem with, in my opinion, with the UAPI header is that it was pretty difficult to add helper functions. For instance, I have GCD and LCM helper functions, and I really need to just put them in the header inline and hope users don't call it. And the same for structs and things like this.
Yeah, no, in that way, I think the VDSO is better because you're going to have like a single definition instead of having, say, UAPI inlining the static inlines into multiple compilation units, for instance.
Yeah. Okay.
Will there be people on the kernel side who will question why it has to be in the kernel at all?
Yeah. I imagine that's going to be pretty hard to justify, to be honest.
I mean, especially if it's in a header only, a UAPI header that's only used by user space and not by the kernel. We just say, well, start that in create a user space project, and that's it.
Maybe there are some drivers which will use it. Maybe it can use by drivers. I don't know. I don't know exactly how drivers will generate constraints. But in some cases, maybe it could help. I don't know.
Yeah, for the constraint generation code, indeed, it could be something that would be useful. Sorry.
The kernel has to at least be able to parse constraint lists or constraint sets.
Yeah.
It has to be able to, at a minimum, extract values from them. It has to be able to merge in its constraint set version, whatever that might be, so that it can support the kind of version resolution we have. I don't know of a for sure use case where you'd have to actually merge two different, individual sets, but you very well could, depending on how the in-kernel buffer sharing stuff evolves. So it might be hard to justify right now, but it feels like it might be a use case in waiting or something like that. Like if we propose it, we might find a use case. But I agree, it might be hard to sell it first.
There's probably something I'm missing then. Why does the kernel need to be able to merge constraints or to parse constraints?
It needs some code to parse, at least be able to look at a constraint type. It needs like a list of all the constraint types and how to parse out the header, which is just like a type and a size, I believe. And it needs to be aware of the versions. So like I said, it might not be a function, it might just be a bunch of shared defines. But you could easily have some helper macros that do that stuff for you.
Right.
That would be, of course, shared with the constraint set merging stuff.
Right.
The hard sell is probably just the constraint set merge function, which you could use to actually perform the version clamping or whatever you call it that the allocator would do. But you wouldn't necessarily have to. It's simple enough. You could open code it. But it'd be nice just to use the shared function if you had it there.
So you need to parse at the allocation step, I think.
Yeah, at allocation time, you need to parse it to be able to apply the constraints. Maybe I misunderstood the question.
Okay, so you foresee that to go. I mean, if we think about the whole stack, we have the constraints that would be merged and then passed to GBM, for instance, for location. Then you foresee GBM passing the constraints as is to the kernel instead of extracting information needs from the constraint and adapting to whatever kernel API is in the backend.
I mean, the gem API, and I'm not familiar with TTM, but the kernel APIs for buffer allocations are driver specific, right? So yeah, maybe userspace could parse it and then translate them to driver specific constraints. It could be an option.
Because otherwise we would have to modify the driver-specific allocation APIs we have today to accept constraints in this generic form instead of whatever they're doing, right?
Oh, I don't catch that. Can you yeah?
I mean, if you want to pass this new model of expressing constraints, if you want to pass those constraints to the kernel and to the backend allocators, which are driver-specific at the moment, that means that the driver-specific APIs we have to locate gem buffers, for instance, would need to be extended to take a set of constraints, right?
Yeah.
And in that case, that means that custom IOCTLs that have a custom set of parameters that are driver-specific would be turned into still possibly and probably one IOCTL per driver, but they would all take the same parameters. So in effect, we would be trying to create a generic allocation IOCTL. Not saying it's a bad thing, but just trying to figure out in which direction we're going.
Yeah, it's not yet clear, I think, how allocation IOCTL would be affected by all of this. It kind of depends if the parameters to express constraints given to the driver in constraint sets are enough or not, I guess.
Yeah, I think it's going to become a question of like how well does this get supported? Because yeah, I mean, the starting point does seem like you'd probably like write some glue code in GBM that takes the constraint sets and passes them down to the existing. I don't know where it intercept it in the DRI layer in GBM itself or down in the Gallium drivers or whatever. But something's going to repack those into the existing octals, probably to prototype this at least. But then as we build up the number of constraints and everything, it becomes a matter of how many parameters you need to add to every single octal to make this work properly. And then you're going to get into the separate debates, of like, do you want a unified ioctal? Or do you want to extend every single ioctal constantly to have these new parameters to be able to satisfy buffer sharing? Or do you always use DMA above heaps when you want to share anything that's non-trivial? So Yeah, you're right. I mean, this leads into a larger conversation, I think. So maybe we can't resolve this open issue until we step into that larger conversation. So I don't know where to go with that.
Yeah.
Good train of thought to bring up.
I mean, there's not ever really been any great love for something, for an interface like that, just because it does imply a lot of complexity and a lot of smarts in the kernel, and opens you up to, is your decision heuristic ABI, and do you need to change it back if it makes something slower for someone? I, to be honest, think it's probably going to stay that way for quite a while, where you have two options of either specialized user space taking a decision and making driver-specific IOPTLs into the kernel to satisfy the allocation, or going fully generic with just DMA heap and size. And I can't say I can really see a middle ground turning up anytime soon, because it's just above the complexity threshold where it gets pretty violently pushed into user space.
Yeah, I quite agree with that. At least that's what I had envisioned. I haven't thought about having some kind of generalization of the allocation AUCTLs until right now. It's not necessarily a bad idea, but I haven't thought about it before. I'm not sure what my opinion would be on it. I don't think it's a blocker, though. I mean, we have things that we have to figure out, and I'm sure that we can, for now, do the adaptation between the generic constraints and the driver-specific IOCTLs in user space. And once we have something that works as a proof of concept, and I think that's a question that needs to be asked and be discussed at that point. But I don't think it blocks development for now, at least.
Okay, that's interesting. Yeah, I wonder if the KMS use case is enough to justify its inclusion in the kernel. We can just discuss this a little bit more. We'll see. Okay. Yeah. Does anybody want to add anything else on the subject of where does the constraint merging library go?
Does it make sense? Go ahead.
I was going to say, I will add, yeah, that it seems likely at some point that at least some thing in the kernel is going to want to merge the constraint sets. Even if it's just some driver thing, like the different planes on a display have different constraints and they need to be merged or something like that to get a clone mode working. I don't know. It doesn't make a bad assumption that it's going to have to be used in the kernel at some point. It might just not be there yet or something.
Maybe you have a constraint set for rotated planes and a constraint set for specific modifier, and then you want to merge these both together if both are used at the same time or something.
Yeah, it seems pretty easy to come up with like theoretical straw man ones. I just don't think we have the silver bullet one yet, like the practical use case in hand. So it's hard to prove right now, but it seems likely we'll get there eventually.
It will need to be justified to the kernel folks. So I think, at least from my point of view, the best course of action, I think, would be to design it in such a way that it could live either in kernel space or user space, or at least not corner ourselves, and making sure that we can keep it flexible. And then, based on what happens in the future, we can decide where to put it.
Yeah, and I assume that means just keep it something that can be header only for now, and then clean it up later.
For instance, yes.
And header only can be header only anywhere.
Yeah. Worst case, if you want to put in user space, it's header only, and you just include a header in a C file, and you compile that in your head library.
Okay.
So if you do it in user space, would it make sense to do it not header only, but in a shared library? Like so that if one thing updates like the merge function, we don't need to update the end things in the stack that are compiled with the header.
Yeah. So that's definitely the case for a shared library. I think my main beef with it right now is that there's no established process to easily share some code between user space and the kernel. I think this has come up before for instance, EDID parsing, because this could be used for both kernel and user space. But you somehow need to keep both in sync. So
I think the moment that we decide to have it live in the kernel, that whether that's VDSO or UAPI header, we can make the implementation of the shared library use that. Like at some point, like if we go with user space for now and then switch it to kernel later, we're going to have that switch over moment anyway when we need to implement the user space component in terms of the kernel component. And that works just as well with a shared library as with the header, right?
So yeah, I guess we could, yeah. So the main issue is that it's a little bit more complicated than just adding a single header in the kernel, because you need to create a new library and then keep it in sync with each kernel release. So that means having some libdrm-like process to update the library.
Yeah, to be fair though, I think that's only really an issue if we expect this to be changing quite a lot. Like, it could be that the code, obviously, whilst we're bringing it up and doing POC type stuff, it's going to change quite a bit, but it could be by the time we've got everything together and it's actually ready to merge into the kernel, then we have to do so few updates that the time it takes for that is less than the time we've taken discussing it.
Yeah, maybe. I'm also not clear if it's a good idea to do a whole different library, or if using libdrm would be fine, for instance. Yeah, I guess questions like this. Because it will be pretty small in the end, so
I think DRM probably makes a lot of sense, because then we have the definitions of the constraints living in the same place as our canonical format and modifier definitions.
Yeah, definitely. That's a good point.
Only question I have there is that okay for like the V4L and camera people to pull in the DRM?
I was just thinking about that. To have headers and DRM directory is not a big issue. We should try to be careful to avoid dependencies on other DRM parts, because this should be usable, for instance, to share buffers between cameras and video codecs. So we don't want to pull anything that requires usage of graphics APIs. But otherwise, having it under the DRM umbrella is not too much of a problem. We're actually reusing the DRM for CCs and modifiers, at least to some extent, in the lead camera project. That's definitely not related to display, but it would be easier from an application point of view to use the same 4CCs for both the camera and the display. So we decided to standardize on the DRM 4CCs and do a translation between default and DRM internally. So yeah, there are precedents, and that's a problem.
But in the existing use case, you only import like define values. You never like import code that actually is meant to execute anything.
Correct.
Yeah, because I think this like standard constraint resolver is something we want to make sure people aren't running multiple different versions of. I'm afraid if, say, people start to bundle this into different shared libraries, and then an application pulls in different shared libraries with different versions, and it ends up with different buffers based on which shared library they use to allocate stuff.
Yeah.
Yeah, I guess it doesn't matter that much if people use two different versions of the merging library, because the merging library just adds its own version to the constraint set. So everything that's not supported will be gracefully fall back to a nearer version. So yeah. I think versioning makes this fine.
Yeah, so I'm not afraid of like having problems, because since we have like versioning support, I'm more thinking that, say,
Okay.
someone shipped, say, some BSP with binaries, and then you get an updated kernel with new constraints. It would be ideal if the existing binaries could automatically handle that, even if it's a new type or a new class of constraint that has been added since the last time it was compiled, basically.
But then presumably those new constraints would already require something like, say your user space media codec component or your GPU driver. Like, most of those constraints are going to require user space updates anyway, right?
Well, it depends. Like in this camera case, you don't want to like update the camera app all the time, even though you're running on a completely new platform, I guess.
Yeah, but libcamera exists for that and does have quite a bit of per device logic in user space, just like we do for GPUs.
Maybe.
But I agree that having to, for instance, recompile compositors will be a little bit unfortunate if you want to have the new constraints in. But yeah.
I mean, if you want to run on a device that uses those new constraints, then one way or another, you need to do something. But if it's just running against a kernel that supports those new constraints, but with devices that don't use them, then clearly we want to be compatible with that. And depending how we ship it, especially as a header only, the question of license need to be considered as well.
Yeah, I think DRM is across the board MIT, and that's useful for BSD too. So maybe it's probably enough.
Yeah, we need
at least it's not
license clearly.
Yeah, definitely.
I haven't really thought about what it should be, but I think that we need to consider that before we release something at least.
Yeah, that's a good point.
I kind of merged some of my thoughts on there into the notes. I think there are cases where it's probably possible that shipping a new kernel would give you everything you need to make use of some new constraints, and there's cases where it wouldn't be. So it'd be nice if you could make that possible, I guess. But yeah, I don't think it's a strict requirement. It's a nice thing.
Okay. Okay.
BDSO solution sounds really clever. If there was a reason to have it in the kernel, the BDSO option sounds super cool. But I'm worried it might be like just unpalatable for people.
It's kind of a way to cheat and distribute a shared library that will always be in sync with the kernel.
On the other hand, you had to use the word cheat there. So.
And the BDSO is kind of designed to actually do that, to provide a standard thing you can link in that's all late.
But I assume we have space constraints there, right?
Well, there are plans to extend the size of the VDSO and have multiple blocks of VDSO because they are planning to add like huge amount of data to be exposed there now. So they are planning to extend it.
So should we move libDRM and Mesa to the VDSO?
Don't forget libc.
Oh god.
The distribution in VDSO.
The VDSO thing is definitely cool, but I wouldn't really count on it because you have to prove that constraint merging should be considered at the same level as get time of day, which is probably a pretty tall order.
Yeah.
The time of day is special.
Yeah. Let's not design a stack so in a way that it would depend on being in the VDSO. But...
Speaking of get time of data, I want to do a time check. We have 20 minutes left.
Okay.
We've probably exhausted this one for now. Let's move on to some of the other ones here.
Yep. So I think we already talked about kind of those two next feedback on EGL, Vulkan, KMS, GBM integration. Question from Roman GG. Oh, can you outline which components have to do what for typical usage of constraints? Maybe I can just sum up very quickly what how it's supposed to work. I think it was it's hard to explain in the talk, but so I think compositors will be would have they need to get constraints from APIs like KMS and OpenGL, and then merge these constraints and then provide them to allocators like GBM.
Don't we need client-provided constraints as well?
So that's that's a good question.
I mean, for cameras, I don't expect the compositor to handle that, so it would be up to the client, right?
Yeah, definitely. So right now, buffers are client allocated in Wayland at least.
Yeah.
So we don't have a good solution yet for clients to allocate buffers that can be used with hardware planes, for instance. But the first step will be to give modifiers hints to clients to say, if you use this modifier, then maybe we can put you on hardware planes. Then we can generalize this to constraints, I think. So give a modifier and also a constraint set together. But we've already been working on a solution for modifiers with Daniel Stone. Unfortunately, it's a little bit stalled right now, but we're getting there. So yeah, I think it would be pretty easy to give the hint to clients and let the Mesa WSI tweak the allocation to take constraint into account. I don't know if you've anything to say about this, Daniel.
No, I don't have anything to add, to be honest. We need to find a new volunteer to push that forward.
Yeah.
Yeah, I think it makes sense. Like we both Wayland with the DMA buff hint stuff and X with DRI3 can dynamically push modifier hints into clients, and I suppose we've just got to extend that. So we're also pushing modifiers and constraints.
So how do you expect that to work if you have a client that wants to capture from a camera and then display the result, either on a hardware plane or just in a texture that can be composited with the GPU?
So usually, basically all of this starts from steady state because you don't have any way of declaring your intention up front. So it's basically the compositor passively observing that I think I could put this buffer on a plane. And so then it works backwards from there. It will take the set of acceptable modifiers and constraints from EGL as well as from KMS, intersect the set of acceptable modifiers, and then from there you have a list of modifiers and a list of per modifier constraints as well. Send those back to the client, and if you're lucky, doing that results in the client allocating something compatible.
Okay, and so the client would take the set of constraints that it gets from the compositor, merge that with the constraints that related to the camera, and then pass the result to the allocator.
Yeah, exactly. But I'd say that if you only give the client modifiers, then there are less chances that it works in the end than if you also pass constraints. Yeah, so constraints definitely are a good improvement for this. Okay. Vendor-specific constraint and the fully opaque constraint, I think we already answered this. And I guess the next big one is heap IDs.
While we're still in the constraints,
sure.
we don't necessarily have to discuss this one right now, but one that I came to think about, and I'm not sure it has been discussed, would be about additional application injected constraints, for instance, allocating a buffer with a cache mapping or uncache mapping for the CPU. That can make a difference when it comes to performances. Is that something that has been taken into account?
Sorry, I didn't quite get that. So a constraint which would say that.
So one example is when you have a client, an application that wants to allocate a buffer to be shared between devices, but also may need to access the buffer with the CPU. And in that case, whether the buffer is mapped cache or uncached to the CPU can make a big difference depending on the use cases. Sometimes it's better to have one, sometimes better to have the other. I was wondering if that has been taken into account in the design at some point.
James, maybe you're more familiar with cached and cached than me.
We didn't walk through that case study, but I think Jason was pointing out yesterday that does. It is similar to how like throwing that in with heaps is kind of similar to how Vulkan handles it, but it does break out cached from heaps. Like I think there's one heap and multiple memory types for the types describe the caching properties. So yeah, that does seem like it would be a separate theme from heaps and constraints as well. I think a good idea would be to walk through that case study. It's not one that we did. We'll try to come up with some examples and walk through them with the design and see if it works. And if not, we should try to decide if that's something that constraints should solve, or if we should kick it down to DMA above heaps or something like that, or what. But I'm hopeful that constraints can solve that. Yeah.
Well, let's not do the case study right now. We're running a bit out of time. But
right.
If we can keep that in mind and keep it a case study, that's done at some point.
I think if we're going into cache behavior as well, which probably makes sense, then we definitely want to look at expanding some of the usage queries, I suppose, in terms of, say, whether or not there are going to be intermediate CPU mappings, if they're going to be read only, read mostly, write only, write mostly.
In addition to read, write only or mostly, there's also sequential or random.
Which might suggest, at least for FreeGL, to expand from a bool to a bit field or enum.
Darn it.
Sorry.
Yeah. Or it might be that that's not the API you query that stuff from. We'll have to see. But yeah, usage is another hard part. It seems like what I like about this design is that you can do stuff like that. You can say query just the graphics usage from EGL, and you might query the CPU usage from GBM or something like that if GBM is managing your mappings. Whatever's doing the mapping stuff, or might even be OpenGL instead of EGL. So whatever can express mapping capabilities, that's probably the API you want to include that usage, and then you just merge the constraints to get the result. In theory. Okay, let's do heap IDs, solve that in 10 minutes.
Yeah. Let's move on to heap IDs. So yeah, there were a lot of questions already yesterday about how we should do heap IDs. There was some, so cacheable maybe. So there are some questions about heap flags. I think cacheable was mentioned, but maybe over. Like should this be separate heaps, or should this be just flags alongside heaps or something else? There are also questions about whether we should some kind of regular memory heap, or in general generic or well-known heaps that are recognized by multiple drivers.
Yeah, I think one of the starting points here might be defining what a heap is. It's not necessarily the case that a heap ID for the purposes of this API has to map to a DMA-buff heap. It'd be nice if it did, but that might not work out right, depending on how DMA-buff heaps have evolved already. I know, like, the things I have in my mind is that I want to have a heap ID that I can expose for my on-GPU memory, the local memory on a video card. And I want to have one that I can expose as the one shared with other things. But the one shared with other things is the hard part, I think. Like, how many of those are there? What are their properties and that kind of stuff?
Yeah, I think it might be worth trying to catch back up with all the heap discussions at Plumbers. I know a couple of the other people who are in there were hoping to join this one, but couldn't make it because of time. But it does sound like the two should very much go hand in hand, because right now heaps are a good idea, kind of wandering around in search of an actually open user space solution. And this is an open user space solution in search of a kernel problem. So
I was going to mention that we have a very good occasion to drive the direction in which DMA heaps will go. So should make sure that it at least go in the direction that's going to work for us.
Yeah, I think, like you were saying, just starting with the two cases of local unshareable versus local, but GTT bar whatever shareable. Just starting with those two, I think, would be super helpful in terms of what kind of API do you need to enumerate and identify those heaps, and what kind of API do you need to discover whether or not those heaps can work with other devices, and which other devices.
The action here would be to set up some kind of meeting with the right people. I'm not really sure who the right people are for DMA-buff heaps, but I'd be happy to meet with them and talk more if this isn't the right time for them.
Yeah, I think was John Stoltz on the sort of Android side. Ezekiel from Collabora is also trying to push it forward for some fun use cases. Yeah, we can definitely dig them up and send them our notes from here and try and get together and mutually push it forward.
Yeah, I think Sumit Samuel would be interested too, and possibly Laura, but...
Yep.
Someone edit those names, I'm having trouble hearing them. Thanks.
Sure.
Okay, I can start an email thread about that. Oh yeah, Laura, yeah. And then hopefully we can set up another meetup for that and just talk about it after everyone's watched the presentation.
Yeah,
Yeah,
good idea.
Yeah, probably not going to solve it in the next 5 minutes. But I can try to put together some more proposals about that in particular too. Maybe kick off the discussion with a little more, something more concrete.
Yeah, I think it would be really interesting as well to see if we can come up with like what seems to be a sensible pathway to actually implementing it. What's the MVP we'd need to prove that this can actually fly? As by the time we get to KMS with these kind of speculative empty frame buffers and lib camera and EGL and everything. Like that's still some distance in the future.
Yeah. Was that a comment towards the whole thing or just the heap IDs part?
No, the whole thing. Because it does seem like, between you and Simon in particular, it's actually, it's got some nice momentum and progress behind it. So if we can figure out how we can keep that and how we can all help each other keep on making progress, that'd be awesome.
Okay. I'll have to talk to my boss at that end then, because he thinks I'm done. Hopefully I can convince him to keep working on this, but yeah. And if someone could review my patches from last year, that'd be helpful too. I still haven't committed my patches from last XDC.
To the allocator, or do you mean the Nouveau modifiers?
The Nouveau modifiers and the prerequisites in the Mesa code.
Okay.
I'm assuming you're signed off by now, but on the one issue at least, but yeah. I don't know whether that's supposed to get those merged.
Yeah, I'm feeling increasingly guilty about that if it's any consolation.
Oh, I feel like that every day. No worries. Yeah, if we had more time, I was going to actually shout that out at the conference to try to guilt trip everybody. Okay, so yeah, I'll take the lead. I'll try to get a proposal. At least I'll set up a mailing email chain, and then we can set up something else after that. I'll try to get some stuff out. And feel free to guilt trip me if I don't follow up quickly on that, because that happens often as well.
Okay.
Sounds good.
Okay, so yeah, I still need to figure out a bunch of stuff. All right, yeah. So yeah, so let's continue to discuss by email, and yeah, of course, feel free to keep sending feedback.
How should we actually do feedback? Should we maybe just do like issues on the allocator repo, or?
There's a new repo that Simon put up on GitLab.
Sorry?
Simon put a new repo up on GitLab that has the merging code. I think it's linked in the slide somewhere.
Yeah, it's at the top of the notes.
Let's do it then. I get random flames on the allocator library for it being there and stuff, so it might get noisy there. And every time you commit there, make the product article, all that kind of stuff.
Sure.
All right. Yeah. So I think we're done then. Thanks everyone for participating, I guess. Yeah, that's a good discussion. Now we know what to do.
Thank you for organizing and all the work you put in there. Looking forward to see that becoming a reality.
Yeah. Little bit, maybe little bit.
So
Slowly.
next year we can have the post-mortem buff where we all just sit around and talk about how great it is that it's finally done. And James, I assume you're going to have to retire when it's done.
That latter part might be true.
Right.
All right, thank you.
Thank you.
All right, thank you very much.
See ya.
See ya.